Hi. In this problem, I'll show you a JEE advanced level question on direct common tangents. You should pay attention to this particular problem because it explains certain ideas that have been asked several times, and you should totally understand the geometry of the problem here. It is very important that you understand the solution because this is an idea that you might not see in books usually. So let's start with the problem. Uh, the centers of two circles, the centers of two circles, C1 and C2, of radii 4 and 9, are 15 units apart, are 15 units apart. L1 is a direct common tangent to these two circles, and there are n different ways in which a third circle C can be drawn to touch both C1 and C2 as well as the line L1. If R1, R2 to Rn are the possible radii of the third circle C, in each of these n configurations, then you have to find out the sum, 18 times the sum where I goes from 1 to n, Ri. Okay, so let's think about the problem. The statement of the problem is non-standard. You might not have seen something like this. So centers of two circles C1 and C2, these circles have radius 4 and 9, and the centers are 15 units apart. Okay, so that is standard information. L1 is a direct common tangent to these two circles. And there are n different ways in which a third circle can be drawn to touch both C1 and C2 as well as the lines L1. So the third circle C has to touch what? It has to touch both C1 and C2, the first two circles, and it also has to touch the line L1, right? The radius of the third circle is R, and there are different ways in which the third circle can be drawn. That is what is meant by n configurations. There are n different ways in which the third circle can be drawn, and in each of the situation we have to find the radius of that third circle and add up all the radii of all of these situations. All the time there are three circles. The three circles are such that C touches C1 and C2. C also touches L1. And obviously the line L1 is direct common tangent to C1 and C2. Right? So let's try to reduce this problem to separate cases and do each case one at a time. Okay. So case one. Let's try to draw a configuration. We have C1 here. C1, and let's say the circle C2 is here, C2, and the third circle is in the middle, something like this, right? Third circle is something like this, and all these circles touch the line L1. So I will redraw C2 a little bit. C2 is like this, right? And this is the third circle C. This is one possibility. Notice here that C touches C1 and C2, and also C touches the line L1, and both the circles C1 and C2 touch the line L1. So now, if this point is A, and this point is B, and this point is C, these are the points of contact of each of the circles with the line L1. We know that the radius of this circle is 9. So this is 9. We know that the radius of this circle is 4. So technically you can find C1, C2, the distance between, actually you don't need to find it, but what you can do is join it like this and find this distance, right? You can find this distance is clearly going to be 9 minus 4, 5. And this distance, you can think of it as, right. So what I want to say here is AC is equal to AB plus BC, right? This is an obvious statement. Now, what is AC? So the centers of the circle have distance of 15. The question had said that the center of C1 and C2 are 15 units apart. So this hypotenuse is 15 and this much is 5. So we can easily find AC here. And AC comes out to be root over 15 square minus 5 square by Pythagoras. So this is 225 minus 25, so root 200, right? Now, let's try to find out AB and BC in a different way. We don't know the radius of the circle C, right? So now I'll focus on the circle C1 and the circle C. This point is A, this point is B. Right. One second. So I will redo it. Here I had found out that AC is equal to root over 225 minus 25. This is root over 200. And what I need to figure out now is AB and BC separately. So let's draw the figure again. This point is A, this point is B. This radius is R, this radius is 9. And I don't know this length, but I can make a guess there. It's because I know that the circles C1 and circle C are touching each other. So what will be C1, the center of this distance from this center to this center? That will be equal to R plus 9, right? Because the radius is R and 9. C1, C2 is equal to R1 plus R2. Also, this distance would be basically 9 minus R, right? So AB length, which is equal to the base here, would be equal to root over 9 plus R whole square minus 9 minus R whole square. So that will be 4 times 9 into R, right? I hope you're understanding what I'm doing. I'm finding AB length by taking these two circles which are touching each other, and by joining the center of the circle, I know the hypotenuse has length R plus 9, the perpendicular has length 9 minus R, and taking the Pythagoras theorem result, you are getting this is the distance of this base or distance AB, right? Similarly, if I do circle C and circle C2, I can do the same thing to find BC. This is B, this is C. I need the base of the triangle again, right? Now this distance will be R plus 4. This distance would be R minus 4 because radius of this circle is 4, right? So the distance BC would be root over r plus 4 whole square minus r minus 4 whole square. So that will come out to be root over 4 times r into 4, right? So these are the distances AB and BC. Root over 36r and root over 16r. And AC was root over 200. We are getting root over 200 is equal to root over 36r plus root over 16r. So that is clearly 6 root r plus 4 root r. So that is 10 root r. And this side you have 10 root 2. So 10 gets cancelled and r is equal to 2. So in this configuration, when the circle C was in the middle and the situation was like this, we are getting radius of the circle will be 2, right? Let's now look at other configurations that are possible. Case 2. Case 2 could be one of the circle A is internally touching. So this circle C1 is internally touching, and this is my circle C2, and this is the line L1. So this is also one possibility. I will draw L1 again properly. So this is one possibility. This is circle C, this is C1, this is C2. This point is A, this point is B. I know the radius here is 9 and I know radius here is 4. I need to find the radius of circle C, right? Notice that this satisfies all the conditions of the problem. The circle C touches C1, touches C2, and it also touches the line, but this time one of the touching is internal touching, right? Okay, great. So let's find out the length AB here. By directly comparing C1 and C2, we can find AB as this AB. So this much distance is basically 9 minus 4, so 5. This distance is 13. So clearly we have, actually I am making a mistake. What is the mistake? Notice that circle C1 is not touching C2. So I have assumed here that C1 was touching C2. That is wrong. What is touching C2? The circle C touches C2 externally, right? So I should draw a figure like this: C, C2, and center of C radius is R, C2 radius is 4, and I can find this distance AB from there. So this length would be R plus 4. This much is R minus 4. And this is the distance that I need, which will be root over R plus 4 whole square minus R minus 4 whole square. So that comes out to 4 into 4 into R. So this is 4 root R, right? We can also do the condition that what is the distance between the centers of C1 and C2? They are not touching each other, by the way. But the question had already told us that the distance between their centers was 15, right? This distance was given as 15. So what I can do is basically find the AB in a different way. It's the same point A and B, but now I'm not using tangency. I'm just using Pythagoras theorem and saying that if this distance was 15 and this much was 5, this length is going to be root over 225 minus 25. So this length is root 200. So here, which circles are we comparing? C1 and C2. They are not tangent to each other. Here we are doing C and C2, right? This is the overall figure, and you should try to understand that in both the cases, I am measuring the length of the side AB one time using C and C2 and one time using C1 and C2. So now, since AB is the same length, you should have root over 200 should be equal to 4 root over R. And this can be simplified as 200 is equal to 16R. And therefore, R is coming as 200 by 16. So that will be 25 by 2 in this case. So in case 1, Our radius of the circle C was 2. In case 2, it is 25 by 2. Let's look at a similar case 3. And this time the internal touching is with circle D or circle C2. So you have, this is my circle C1, this is my circle C, and this is my circle C2. This is my point B, this is my point A, this is the line AB. So exactly same situation as before, but this time circle C has circle C2 inside it, right? Again, I will try to find the length AB in two different ways. First, by comparing C1 and C2, AB, and that is the same as before. The distance between the centers was given as 15. We know this difference is 9 minus 4, 5. So this length is root 200. And now I will do the same length AB, but now I'll use C1 and C to figure it out, right? So C1 and C, you should realize that this is 9, this is R, and I have to do this distance is 9 plus R, and this distance is R minus 9. And this AB length would be the difference between 9 plus R whole square minus R minus 9 whole square. So that comes out to be 36R, root 36R. And I have to equate this to this because both are measuring the same length AB. So I'll say root 36R is equal to root 200. So R is coming out to be 200 by 36. Divided by 4, you will get 50 by 9. So this is the radius of the circle in the third case, case 3. And finally, we can do case 4, where I will draw the figure here. So case 4 is the orientation where you have circle A, circle C2. This is circle C1, circle C2, and there is a third circle C which touches both of them like this. This is also a possibility, right? So here, this is my circle C. It has radius R, and this has radius 9, and this has radius 4. And I am still trying to find A, B, and this point. Let's label this point as this point of contact as C. So I can say easily that AB is equal to AC plus BC, right? And AB distance, I have already found several times. AB distance is root 200. How do I do that? Using circle C1 and circle C2. I already know that they are having length 15 and this difference is 5. We have done this calculation several times. Now I will use the length AC. I will try to find using circle C1 and circle C. They are touching each other. And this is R, and this is 9, and this is AC. So I have 9 plus R and 9 minus R here, and this will come out to be root 36R, right? Correct. Wait, I have already done this case actually. So I'm making a mistake. If you recall, I had already done this case. This was case 1. So I will get an equation like root 36R plus root 16R. So this configuration was already covered and radius came out as 2 in this case. So I will do the actual fourth configuration. This fourth configuration looks like this. Circle A is like this, circle C1. This is a smaller circle C2. Okay, I will draw a figure, slightly better figure. I have a circle here. I have to make a big circle C here. It touches this, and I have to make smaller circle C2 here. So this is C1, this is C2, and this is C. Radius of this is 9, radius of this is 4, and radius of this is R. And let's label the points A, B, C here. Notice that the circle C touches C1 also and C2 also, and it touches the line as well. But this time we have AC is equal to AB plus BC, and AC is actually going to be this distance, and that will be 9 plus R, and this is 9 minus R, so it is root 36 R here, is equal to AB. AB is this distance, and we can calculate that this is 15, so this is root 200. So root 200, and BC is going to be this distance, BC, and that will come using root, this will be R plus 4, and this length is basically R minus 4, and this length will come out to be root 16R. So the equation is slightly different here, right? So you're getting 6 root R minus 4 root R, so 2 root R is equal to root 200 in this case, and you get 4R is equal to 200. So R is equal to 25, right? One second. Let me just check my calculations. Not R is equal to 25. 4R is 200. R is equal to 50. Right. So this is my case 4. So think of what situations we have seen. We saw the situation where circle C was in the middle of the two circles. We saw the situation where circle C was bigger and internally touching C1 and C2 like this. Then we saw a situation where circle C was bigger, but it was touching C2 and C1 was like this. And now we are seeing that circle C is on the side of both of them, and C2 is in the middle and it is touching both like this. Other than these 4 situations, you will not be able to come up with any other configuration. And remember the radiuses that we have gotten. Radius 1 was 2. Radius 2 in the second configuration had come out as 25 over 2. Radius 3 in the third configuration was 50 over 9. And finally, in the fourth configuration, radius is 50. So the required sum is 18 times the required sum is 2 plus 25 by 2 plus 50 over 9 plus 15. So we are getting 36 plus 25 into 9, 225 plus 100 plus 50 into 18. So that will be 100 into 9, so 900. So this becomes 1125, 1225 plus 36, so 1261. So this is the required answer. And we have understood how to use geometry and Pythagoras theorem and understand the different ways in which 3 circles can be arranged in such a way that one circle touches the other 2, whereas all 3 circles have a common direct common tangent, right? So hopefully you've learned how to verify these configurations and apply Pythagoras theorem to figure out the relations between the radiuses. If you know 2 of the circles radius, the third circle's radius, you can see how we have found by using geometry. So think about it. We were given information about 2 circles, C1 and C2. We were told that the distance between their centers was given and their radiuses were given, 9 and 4. And we have found in all situations what is the radius of the third circle which touches both of them and is common tangent to the same direct common tangent, right? We were able to find the radius of this third circle in every situation, in every configuration. You should go through the configurations yourself so that you understand how we found the third circle. It's basic geometry and Pythagoras theorem, but if you see it for the first time in the exam, you might get stumped. So make sure you go through the problem and its solution carefully so that you understand what is going on. So that finishes off the problem. The answer to the problem was 1261. That's it for this video. I'll see you next time.